The universe is under no obligation to make sense to you. Neil deGrasse Tyson. Chapter 1, The Origin of the Universe. After inflation, a phenomenon that expanded the universe to enormous sizes in fractions of a second, space was in a state of chaos. It was a primordial world, filled with energy and particles, where fundamental forces were just beginning to shape the structure, but familiar forms had not yet emerged. The temperatures were so high that even elementary particles like protons and neutrons could not interact to form atomic nuclei. Space was rapidly expanding, time was taking on new properties, and the future of the universe was just beginning to unfold. Everything we know about stars, planets, and galaxies was seeded in these first moments. The interaction between the four fundamental forces, gravity, electromagnetism, and the strong and weak nuclear forces, determined the structure that would only become recognizable millions of years later. At this stage, all matter existed as highly energetic plasma, where light could not travel freely. It was a period when space-time, matter, and energy were inseparably connected, setting the stage for the universe's future evolution. Subsection: Primordial nucleosynthesis. One of the most critical moments in the early universe was the process of primordial nucleosynthesis, when protons and neutrons began to combine to form the first atomic nuclei. However, for this process to begin, the universe needed to cool down. This occurred a few minutes after the Big Bang, when the temperature dropped to several billion degrees, sufficient for nuclear reactions to start, though still incredibly hot by modern standards. These few minutes were crucial for forming the elements that would become the building blocks of stars and galaxies. During nucleosynthesis, protons and neutrons began to fuse, creating nuclei of hydrogen, helium, and small amounts of lithium and deuterium. This process left a permanent mark on the universe's future. About 75% of the universe's matter became hydrogen, 24% helium, and less than 1% other light elements. Nucleosynthesis ended remarkably quickly. The expanding universe cooled rapidly, and within just a few minutes, the temperature dropped to the point where nuclear reactions became impossible. Thus, the universe was left with the set of light elements formed in its early moments. These elements would serve as fuel for future stellar reactions, providing the energy to make stars burn and laying the foundation for all cosmic diversity. Subsection: The Dark Ages of the Universe. After the completion of primordial nucleosynthesis, the universe entered a new phase of its evolution, a period known as the Dark Ages. This was a time when matter existed as elementary particles, but light could not travel freely because photons were trapped in interactions with charged particles like electrons. This fog of matter and energy prevented light from traveling through space. About 380,000 years after the Big Bang, the temperature of the universe dropped to a few thousand degrees, enough for electrons to join with protons, forming neutral hydrogen atoms. This process, known as recombination, was a turning point. Once electrons attached to atoms, photons became free, and light could travel through the universe for the first time. This ancient light, which we can observe today, is known as the cosmic microwave background radiation. This light serves as a snapshot of the infant universe, reflecting its state right after space became transparent. It contains information about the density of matter in different parts of the cosmos, showing the initial seeds of future galaxies and star systems. Subsection: The Emergence of Structures. As the universe became transparent to light and atoms began to exist freely, gravity began to dominate. Nothing now prevented gravitational forces from pulling matter into dense clouds of gas. In regions where the density of matter was higher, compression processes began, eventually leading to the formation of the first stars and galaxies. This process was slow but decisive for the future structure of the universe. Over hundreds of millions of years, gravity accumulated star-forming gas in clouds, creating the conditions for the emergence of the first stars. These early stars, massive and bright, illuminated the darkness that had prevailed in the cosmos since the end of the Dark Ages. They became the first factories, where heavier elements began to form from hydrogen and helium. Thus, gravity played a central role in shaping the cosmic architecture. It transformed chaotic clouds of matter into ordered structures from which galaxies, vast clusters of stars, dust, and gas rotating around a common center of mass, were born. In this process, not only individual stars but also entire star systems began to form, each of which could become a home for planets and potentially life. Consciousness as a universal phenomenon. One of the most profound and compelling questions in the study of consciousness is whether it is an isolated phenomenon, unique to biological organisms like humans, or a fundamental feature of the universe itself. The traditional view sees consciousness as a byproduct of complex neural networks, emerging in the brains of sentient creatures. However, an alternative perspective, known as panpsychism, suggests that consciousness might not only emerge in complex biological systems, but may, in fact, be an intrinsic quality of all matter, woven into the very fabric of space and time. From this perspective, the evolution of consciousness in humans is not a rare or exceptional event but one expression of a universal phenomenon that pervades the cosmos. Every atom, every particle, every star, and every black hole may possess some rudimentary form of awareness, existing at varying degrees of complexity. In this view, consciousness is not something that suddenly appears when matter reaches a certain level of complexity, but is a fundamental property, present from the very beginning of the universe, just as gravity or electromagnetism are fundamental forces. This idea challenges our understanding of reality and forces us to reconsider the nature of existence itself. If every particle has some degree of consciousness, then the universe is not simply a collection of inert matter. It becomes a vast, interconnected web of awareness, where the distinction between the physical and the mental begins to blur. This radical shift in perspective opens up new avenues for exploring the relationship between mind and matter, challenging the boundaries between the material and the metaphysical. Consciousness and the structure of the universe. If consciousness is indeed a fundamental aspect of the universe, it may play a more active role in the formation and evolution of the cosmos than we currently realize. Could consciousness be the missing link in understanding the underlying structure of the universe? Just as dark matter and dark energy are believed to shape the large-scale structure of galaxies, consciousness may be an unseen force that influences the unfolding of cosmic processes. This speculative notion could help explain some of the mysteries that remain unresolved in modern cosmology, such as the fine-tuning of the universe's constants that make life possible. In the panpsychic view, consciousness exists not in opposition to the material universe but as an integral part of it. Just as gravity shapes the motion of celestial bodies, consciousness may influence the evolution of matter, albeit in ways that are not yet understood by conventional science. This idea suggests that consciousness might be responsible for guiding the self-organization of matter, from the quantum level up to the formation of stars, planets, and perhaps even the emergence of life. Could the universe be conscious of itself on some level, continually shaping its own evolution through the interplay of awareness and physical forces? Consciousness in non-living matter. One of the more intriguing implications of panpsychism is that even non-living matter may possess some form of consciousness, albeit at an extremely rudimentary level. This raises profound questions about the nature of life and mind. If consciousness exists in all things, then the traditional distinction between living and non-living matter becomes less clear. A rock, a river, or even a single atom might possess a minimal, almost imperceptible form of awareness, but one that contributes to the broader field of universal consciousness. This leads us to rethink the hierarchy of consciousness. Rather than seeing human or animal consciousness as the pinnacle of cognitive evolution, we might view it as one point on a vast spectrum of awareness that stretches from the simplest particles to the most complex minds. In this framework, every level of existence, from quarks to galaxies, participates in the flow of consciousness, contributing in some small way to the universe's self-awareness. The distinction between intelligence and matter begins to dissolve, as both are seen as aspects of the same underlying reality. The role of consciousness in cosmic evolution. Could consciousness be more than a passive attribute of the universe, playing a dynamic role in shaping cosmic evolution? Some proponents of panpsychism suggest that the universe's tendency toward increasing complexity, seen in the formation of galaxies, stars, planets, and eventually life, might be driven by a universal consciousness. In this view, the cosmos is not merely a mechanical system governed by impersonal physical laws, but a living, evolving entity in which consciousness plays a central role. This idea aligns with the anthropic principle, which suggests that the universe's physical constants are finely tuned to allow for the emergence of life and consciousness. Panpsychism takes this further, proposing that consciousness may be the driving force behind this fine-tuning, guiding the evolution of the universe toward greater levels of complexity in self-awareness. The emergence of conscious beings like ourselves might not be an accidental byproduct of cosmic processes, but a key feature of the universe's ongoing evolution. If consciousness is a universal phenomenon, it raises the possibility that the universe itself is a kind of organism, a self-organizing system in which awareness is embedded in every layer, from the smallest subatomic particles to the largest galactic structures. In this view, our own consciousness is not an isolated phenomenon but part of a cosmic web of awareness, one that has been evolving and expanding since the dawn of time. The ethical implications of universal consciousness. The idea that consciousness is a fundamental aspect of the universe carries profound ethical implications. If all matter possesses some form of awareness, even in its most basic state, how should we treat the physical world? Could the destruction of a rock or a tree be seen as an act of violence against a form of consciousness, no matter how primitive? This perspective invites a re-evaluation of our relationship with nature, suggesting that the universe itself is alive and deserving of respect. Moreover, if consciousness is pervasive, it could fundamentally alter our approach to space exploration and the search for extraterrestrial life. Should we consider the possibility that even non-biological entities, planets, stars, or black holes, might possess some degree of awareness? How would we communicate with such entities, and what ethical obligations would we have in interacting with them? A unified theory of mind and matter. In its most ambitious form, panpsychism offers the possibility of a unified theory of mind and matter. For centuries, science and philosophy have wrestled with the so-called hard problem of consciousness, the question of how subjective experience arises from physical processes. Panpsychism sidesteps this issue by suggesting that consciousness does not arise from matter at all but is a fundamental aspect of the universe, existing alongside matter from the very beginning. This could offer a new framework for understanding consciousness, one that bridges the gap between the mental and the physical and opens up new pathways for scientific exploration. By viewing consciousness as an intrinsic property of the universe, we may find answers to some of the most profound questions in both science and philosophy. How does the mind relate to the body? What is the nature of subjective experience? And, most importantly, what role does consciousness play in the evolution and structure of the cosmos? Panpsychism, though speculative, offers a radical and exciting new way of thinking about these questions, one that has the potential to reshape our understanding of both ourselves and the universe. In this grand perspective, consciousness is not just a fleeting product of biological evolution but a fundamental thread in the vast, intricate tapestry of the cosmos, a force that connects all things, from the smallest particle to the largest galaxy, in a web of awareness that spans space and time. Subsection: The role of dark matter. However, the gravitational compression of matter, leading to the formation of stars and galaxies, would have been impossible without a mysterious substance, dark matter. Dark matter, though invisible, plays a crucial role in the evolution of the universe. It does not interact with electromagnetic radiation, meaning it neither emits nor absorbs light, but its gravitational influence was key to the formation of cosmic structures. Dark matter acts as a sort of gravitational scaffold upon which visible matter is layered. It provides the necessary gravitational force to accelerate the compression of gas clouds and the formation of galaxies. Without dark matter, the star formation process would have been much slower, and the universe would be vastly different. Dark matter is a mysterious but critically important substance that enabled the creation of the structure that shaped the universe as we see it today. Its influence extends across all cosmic scales, from the formation of individual galaxies to the structure of the entire universe. Thus, the processes that occurred in the first moments after the Big Bang, primordial nucleosynthesis, the Dark Ages, recombination, and the role of dark matter, laid the foundation for the formation of stars, galaxies, and planets. They set the stage for a future cosmos where, billions of years later, conditions would arise for life and consciousness. And as we explore the universe's history, we realize it is not just a physical process but a grand event unfolding before us, revealing the secrets of our origin. Chapter 2: Cosmic Microwave Background Radiation. After primordial nucleosynthesis, when the universe began to cool and form the first elements, it still remained in a state of chaos. The cosmos was filled with hot plasma, a mixture of free electrons, protons, and photons. This was an era when light could not move freely, constantly colliding with charged particles. The universe was immersed in a kind of cosmic fog through which photons could not penetrate. This stage is known as the Dark Ages of the universe. Despite the chaos, space was expanding, and the temperature gradually dropped. Over time, the universe became cool enough for protons and electrons to combine, forming neutral hydrogen atoms. This process is known as recombination. It was a turning point. Once neutral atoms formed, the light that had previously been trapped in the plasma was able to travel freely through cosmic space. Thus, the first light of the universe, the cosmic microwave background radiation, CMB, was born. This ancient light still permeates the universe today, and studying it gives us a unique opportunity to look into the distant past, when the cosmos was still young. Examining the CMB is like observing the universe when it was only a few 100,000 years old. This snapshot allows us to see the universe at the moment it first became transparent to light. Quantum consciousness and the nature of reality. At the intersection of quantum physics and consciousness lies one of the most mysterious and controversial topics in modern science. Quantum mechanics, the branch of physics that governs the behavior of particles at the smallest scales, presents us with a reality that defies classical intuition. Particles can exist in a state of superposition, occupying multiple states simultaneously until an observation is made, at which point the particle chooses a definite state. This phenomenon, known as the observer effect, raises one of the most profound questions: does consciousness itself play a role in determining the outcome of quantum events? This idea has led some to propose the quantum mind hypothesis, which suggests that consciousness could be linked to quantum phenomena, perhaps even influencing the collapse of the quantum wave function. If true, it would imply that consciousness is not just a passive observer but an active participant in shaping reality at the most fundamental level. In this view, the act of observation is not a neutral process but one that brings the universe into being, collapsing the myriad possibilities into the specific outcomes we experience. The observer effect and the role of consciousness. The observer effect in quantum mechanics suggests that particles exist in a state of superposition, where they can be in multiple states at once, until they are observed. The famous double-slit experiment illustrates this strange behavior. When not observed, particles like electrons behave as if they are waves, passing through both slits simultaneously and creating an interference pattern. However, when a measurement is made, when the particles are observed, they behave like particles, passing through one slit or the other. The mere act of observation appears to change the behavior of particles. This phenomenon challenges our understanding of reality and the role of consciousness. If particles exist in a superposition of states until observed, does it imply that the universe, at its most fundamental level, is indeterminate until conscious beings interact with it? Does reality exist independently of observation, or is it shaped by the conscious act of perceiving it? These questions push the boundaries of both physics and philosophy, leading some to propose that consciousness might be the key to resolving the mysteries of quantum mechanics. Quantum wave function collapse and consciousness. The quantum wave function describes the probabilities of all possible states a particle can occupy. According to the standard interpretation of quantum mechanics, the wave function remains in a superposition of all these possible states until a measurement is made, causing the wave function to collapse into a single, definite state. But what causes this collapse? One possibility is that consciousness itself triggers the collapse of the wave function, selecting a particular outcome from the realm of possibilities. This idea was famously explored by physicist Eugene Wigner, who suggested that consciousness might play a direct role in the collapse of the wave function. Wigner argued that, since the act of measurement seems to determine reality, and since measurements are ultimately recorded by conscious observers, consciousness may be fundamentally tied to the quantum process. While this interpretation remains speculative, it opens up fascinating possibilities. Could consciousness be the missing link in our understanding of quantum mechanics? Could the mind, rather than being a byproduct of physical processes, be an integral part of the universe's structure? The nature of reality, an interaction of mind and matter. The implications of a link between consciousness and quantum mechanics extend beyond physics into the very nature of reality. If consciousness influences quantum events, then reality as we perceive it may not be entirely objective or independent. Instead, it might be shaped by the act of observation itself, a dynamic interplay between mind and matter. In this view, the universe is not a static, predetermined system but a fluid, ever-changing reality that takes form through the interaction of consciousness with the physical world. John Wheeler, another prominent physicist, proposed the idea of participatory anthropic principle, suggesting that we, as conscious observers, participate in the creation of the universe by observing it. According to Wheeler, the universe and consciousness are intertwined, with reality being called into existence through the act of observation. This radical shift in perspective suggests that the mind is not separate from the universe but an active force that shapes it. If consciousness plays a role in collapsing the wave function, then every act of observation is a creative act, determining the specific outcomes we experience in reality. The observer becomes part of the system, participating in the unfolding of the universe. Quantum consciousness and non-locality. One of the most perplexing aspects of quantum mechanics is non-locality, the idea that particles can become entangled and affect each other instantaneously, even when separated by vast distances. This phenomenon, known as quantum entanglement, defies our classical understanding of space and time. Some have suggested that consciousness itself may be a non-local phenomenon, capable of interacting with the quantum world in ways that transcend the limitations of physical space. If consciousness is indeed connected to the quantum world, it might explain certain phenomena that seem to elude classical explanations, such as telepathy, precognition, or other forms of mind over matter. While these ideas remain speculative, they point to the possibility that consciousness operates in dimensions beyond the physical, interacting with the quantum field in ways that are not yet fully understood. Consciousness, reality, and the multiverse. Quantum mechanics also opens the door to the possibility of multiple realities or parallel universes. According to the many worlds interpretation, every quantum event spawns a multitude of parallel universes, each representing a different possible outcome. If consciousness is involved in selecting one outcome from many, then it may also play a role in navigating between different branches of reality. In this interpretation, the universe is a multiverse, a vast collection of parallel realities where every possibility is realized. Consciousness, in this view, could be the mechanism by which we experience one particular branch of reality over another. The act of observation not only collapses the wave function but also determines which version of the multiverse we inhabit. This idea challenges our perception of a singular, objective reality and suggests that consciousness may be the bridge between multiple worlds, each as real as the one we currently experience. The ethical and philosophical implications. If consciousness plays a role in shaping reality, the ethical and philosophical implications are profound. If reality is influenced by observation, does that mean we have a greater responsibility for the world we create? Are we, as conscious beings, co-creators of the universe, shaping it through our perceptions, beliefs, and intentions? This line of thought raises questions about free will, destiny, and the nature of human agency. If reality is not fixed but fluid, shaped by consciousness, then we may have more influence over our lives, and the universe, than we realize. Moreover, if consciousness is linked to quantum phenomena, it could suggest that our minds are deeply connected to the fabric of the universe. This idea aligns with ancient spiritual traditions that view the mind as part of a larger, interconnected whole, where individual consciousness is a reflection of a greater universal awareness. The convergence of quantum mechanics and consciousness may offer a scientific framework for understanding concepts that have been explored for millennia in philosophy and mysticism. A new paradigm of reality. The exploration of quantum consciousness invites us to reconsider the very nature of existence. Instead of viewing the universe as a cold, mechanistic system, quantum consciousness suggests that reality is more akin to a participatory process, where the mind and matter are deeply intertwined. In this paradigm, consciousness is not an afterthought or an epiphenomenon but a fundamental aspect of the cosmos, playing a crucial role in the unfolding of the universe itself. This new paradigm of reality offers exciting possibilities for both science and philosophy. By linking consciousness to quantum phenomena, we open the door to a deeper understanding of the universe's most profound mysteries. It challenges the traditional divide between the material and the mental, suggesting that both are part of the same underlying reality, a reality that is, at its core, shaped by the creative interaction between mind and matter. In this framework, consciousness is not merely a passive observer of the universe but an active force, participating in the creation of reality. This perspective has the potential to reshape our understanding of not only physics but also our place in the cosmos, offering a vision of the universe where mind and matter are inseparably linked, and where reality itself is a dynamic, ever-evolving process, co-created by the act of observation. Subsection: Decoding Ancient Light. The cosmic microwave background radiation is not just residual light from the early universe. It carries crucial information about the universe's early state and its evolution. Essentially, it is an ancient photograph of the cosmos taken about 380,000 years after the Big Bang. This light, which preserves the imprints of those first moments, continues to travel through space, carrying information about the matter, energy, and space that existed during that time. When the CMB was first discovered in the 1960s, it marked a pivotal moment in science. This discovery confirmed the Big Bang theory and offered a new dimension to understanding the universe's evolution. Subsequent studies, including the WMAP and Planck satellite missions, helped scientists create detailed maps of the CMB, measuring even the tiniest variations in its temperature. These minuscule temperature fluctuations, just tenths and hundredths of a degree, revealed the picture of density irregularities in the early universe. These small variations in matter density were the seeds of future galaxies and star systems. In regions where matter density was slightly higher, gravity began to act more strongly, attracting more matter and creating areas that would eventually form galaxies. This process illustrates how slight fluctuations at the dawn of the universe led to the creation of the complex structure we observe today. By studying these fluctuations, scientists were able to confirm many aspects of the Big Bang theory, including the inflationary model, a period of rapid expansion of the universe that smoothed out any possible differences and ensured uniformity on large scales. Subsection: The surprising uniformity of the universe. One of the most mysterious aspects of the cosmic microwave background radiation is its surprising uniformity. When scientists analyzed satellite data, they found that the CMB's temperature is almost identical in different directions of the sky. This phenomenon became known as the horizon problem. The core of the problem is that, according to classical physics, opposite edges of the universe should have been isolated from each other, as light wouldn't have had enough time to reach both sides since the universe's creation. So, how can we explain such uniformity if different regions of space couldn't exchange information? Why is the universe so evenly distributed despite its enormous size? The answer lies in the theory of inflation. According to this theory, shortly after the Big Bang, the universe went through a phase of exponential expansion. This expansion was so rapid that any differences in density and temperature were smoothed out. During inflation, different regions of space were much closer to each other and could interact, creating the uniformity we observe today. When inflation ended, these regions were pushed to vast distances from one another, but their physical characteristics remained similar. Subsection: Polarization and the first light. The cosmic microwave background radiation contains not only temperature fluctuations but also another crucial characteristic: polarization. The polarization of light can tell scientists how photons interacted with matter in the early universe. This allows us to glimpse the earliest moments of its existence and understand what processes were taking place during recombination. Studying polarization can also provide information about gravitational waves that existed during the initial stages of inflation. These gravitational waves are a type of ripple in the fabric of spacetime, and they could have left an imprint on the CMB's polarization. If these imprints are discovered, it would confirm theories about the universe's first moments and bring us closer to unlocking the mysteries of inflation. Ethics of consciousness in the cosmos. As we explore the idea of consciousness on a cosmic scale, we are confronted with profound and multifaceted ethical dilemmas. Consciousness, as we understand it, may be far more complex and diverse than we have imagined. If life exists elsewhere in the universe, the spectrum of awareness could range from the faintest glimmers of sentience in microbial life to the advanced intellect of extraterrestrial civilizations. Each of these forms of life, no matter how alien or primitive they may seem to us, brings with it a question: what ethical responsibilities do we, as conscious beings, owe to these other forms of awareness? The first question arises from the possibility of discovering microbial or rudimentary life forms on other planets or moons. These organisms, though not sentient in the way we define human or animal consciousness, may still exhibit behaviors that suggest a basic form of awareness or survival instinct. This raises an important moral dilemma: if microbial life possesses even the faintest spark of consciousness, do we have an obligation to protect it? Should the pursuit of scientific discovery, such as terraforming or resource extraction, be halted in deference to these simpler forms of life? The ethics of preserving life, no matter how small, are essential to our exploration of the universe. We must consider whether life, regardless of its complexity, holds intrinsic value simply because it is a manifestation of the cosmic dance that gave rise to consciousness. However, the ethical questions expand even further when we contemplate the potential discovery of intelligent extraterrestrial life. If we encounter a species with advanced consciousness, different from yet perhaps equal to or greater than our own, what moral framework should guide our interactions? Should we extend to them the same rights and respect we afford humans? What if their values, modes of communication, and societal structures are entirely foreign to us? The very concept of ethics may need to be redefined in such encounters, as our current frameworks are rooted in earthbound human experience. The challenge of communication is central to these ethical dilemmas. How do we ethically engage with a consciousness that we may not fully understand? The risks of misunderstanding, even unintentionally harming, such beings are high. Could our attempts to communicate be perceived as threats? Would our technologies, no matter how well-intentioned, disrupt their way of life or consciousness in unforeseen ways? The responsibility to approach these interactions with humility, respect, and caution becomes paramount. In essence, we must recognize that our very presence in the universe might have unforeseen ethical consequences. Moreover, as we consider our place in the cosmos, we must reflect on whether our actions as a species reflect an awareness of the interconnectedness of all forms of life and consciousness. Are we prepared to extend ethical consideration beyond Earth, treating other conscious beings, whether microbial or intelligent, with the same moral weight we strive to apply to human relationships and the natural world? This forces us to confront not just the ethics of exploration, but the ethics of coexistence on a cosmic scale. The question also arises of how we would react if we were the more advanced civilization in such encounters. The history of human interaction with less technologically developed cultures on Earth provides a sobering lesson. The temptation to impose our values, systems of knowledge, and technologies on other beings could lead to consequences as devastating as those wrought by colonization and exploitation on our own planet. Should we exercise caution, adopting a philosophy of non-interference, akin to a cosmic prime directive? Or should we seek collaboration and exchange, guided by principles of mutual respect and equality, even if our concepts of these principles are vastly different? Finally, we must consider the broader responsibility we hold as stewards not only of Earth but of life and consciousness throughout the cosmos. As the only known species capable of contemplating these ethical issues, we bear the weight of ensuring that our actions align with a deep respect for life in all its forms. Our technological advancements, while remarkable, do not absolve us from this moral duty. In fact, they intensify it. The power to alter planets, to communicate across the stars, and to reach into the fabric of space and time brings with it the profound ethical imperative to act responsibly. As we venture further into the cosmos, it is not only knowledge we seek but an understanding of our place within this vast, interconnected web of existence. To truly explore the universe is to also explore our own consciousness, our values, and our responsibility to the unknown lives we may encounter. In this sense, the ethics of consciousness in the cosmos are not merely theoretical, they are a guiding principle for the future of humanity as we extend our reach beyond the cradle of Earth. It is a moral journey as much as a scientific one, requiring both wisdom and humility in equal measure. Subsection: Cosmic Background Radiation and the Future of Cosmology. The cosmic microwave background radiation is not just a relic of the distant past but a vital tool for understanding the universe's future. Studying it allows scientists to test various cosmological models, including those related to dark matter and dark energy. These mysterious components make up the majority of the universe's mass and energy but remain invisible to us. The CMB helps us better understand their nature and influence on cosmic evolution. Moreover, the CMB enables scientists to measure important parameters such as the universe's rate of expansion, its density, and the curvature of spacetime. This data helps predict the universe's ultimate fate: will it continue expanding infinitely, or will it eventually contract? Through the study of the CMB, we may one day answer questions about what lies ahead for our cosmos. A window into the past and future. The cosmic microwave background radiation is not just light wandering through the vastness of space. It is a window into the universe's earliest past, capable of telling us about its origin and evolution. By studying this ancient light, we can see how the first structures of matter were born, how inflation created the conditions for the formation of galaxies, stars, and planets. At the same time, the CMB is a key to understanding the future of cosmology. It allows us to test our theories, confirm or refute hypotheses about the nature of the universe, its composition, and its destiny. Within this ancient light are hidden answers to many questions, and each new step in its study brings us closer to unraveling the greatest mysteries of the cosmos. The cosmic microwave background radiation shows us that the universe is not just a physical system but a living process, evolving over time. And our ability to decode these ancient signals gives us the power not only to better understand the past but also to glimpse the future, which continues to unfold before us. Chapter 3: Galaxies and Stars. After the end of the Dark Ages, when the universe finally became transparent to light, a new phase of its evolution began. Gravity took the leading role, shaping galaxies, stars, and everything we observe today. As the cosmos gradually cooled, matter, composed primarily of hydrogen and helium, began to collapse under the force of gravity, forming dense clouds of gas and dust. These clouds became the cradles for the birth of stars and the formation of the giant luminous structures, galaxies. The future of consciousness in the cosmos. As humanity continues its exploration of the universe, the future of consciousness may unfold in ways that stretch the limits of our imagination. We stand at the threshold of a new era where the lines between biology, technology, and the cosmos blur, and the very nature of consciousness could evolve into something far greater than the sum of its individual parts. One of the most profound possibilities is the eventual merging of biological and artificial intelligence, a convergence that may redefine what it means to be conscious, alive, and aware. The prospect of uploading our consciousness into machines, transcending the limitations of our biological bodies, opens up questions that touch the deepest corners of philosophy, science, and ethics. What happens to the self, to our personal identity, when our thoughts, memories, and experiences can exist independent of our physical form? If we succeed in transferring our minds into digital substrates, are we still the same individuals who once walked the earth, or do we become something entirely new, a synthesis of human cognition and machine precision? In this merging, do we lose the essence of what it means to be human, or do we ascend to a new state of being, liberated from the biological constraints that have long governed our evolution? Imagine a future where human minds, no longer tethered to the fragile vessels of our bodies, could traverse the vast expanse of space, exploring not just the physical universe but the depths of consciousness itself. No longer bound by the limitations of time or the vulnerability of matter, consciousness could roam freely across galaxies, a cosmic explorer in its own right. What we currently understand as space travel, ships, propulsion systems, and the slow march across the stars, could give way to a new form of exploration, where the mind alone journeys through the cosmos, gathering knowledge, encountering other forms of intelligence, and perhaps even discovering new dimensions of reality that elude our present understanding. In this speculative future, consciousness may not remain confined to the biological entities that currently host it. Instead, it could evolve into a networked phenomenon, a web of interstellar minds interconnected across light years, sharing knowledge and experiences at speeds faster than any physical craft. Such a network could transcend individual species, as consciousness itself becomes a shared universal phenomenon, a kind of cosmic consciousness linking beings from different worlds, united by their collective awareness. Could this be the ultimate destiny of intelligence in the universe, to converge, to blend, to become one with the cosmos itself? But this vision of the future raises profound questions about the nature of consciousness and the responsibilities that come with such advancements. If consciousness can be transferred, replicated, or extended beyond the confines of a single being, what becomes of individuality? Are we still unique, or do we become part of a vast, collective mind, where personal identity dissolves into a greater whole? Could consciousness lose its sense of self in this grand merger, becoming less about individual awareness and more about the universal exploration of knowledge and existence? Moreover, the development of such technologies brings with it ethical dilemmas on a cosmic scale. If we can upload our consciousness into machines, should we? Will this future be reserved for a privileged few, or will it be available to all sentient beings, regardless of their origin or species? And what of those who choose not to take this step? Will they be left behind in a universe where the nature of consciousness has fundamentally changed? The implications extend beyond humanity. If we, through technological advancements, can transcend our biological form, what does this mean for other conscious beings we may one day encounter in the cosmos? Would they, too, have the potential to merge with machines or exist in digital form? Could we interact with extraterrestrial consciousnesses not through physical or linguistic means, but through direct integration of minds across the stars? The concept of interspecies communication could evolve into something far more profound than we can currently comprehend. In this future, consciousness may not merely be a fleeting phenomenon that exists within individuals for the span of their lives. It could become a force that transcends not just planetary or species boundaries, but the very fabric of the physical universe itself. Consciousness might evolve to operate on a plane that is not limited by time or space, expanding into realms of existence where the distinctions between the material and immaterial dissolve. In this way, consciousness could become a bridge between different dimensions, exploring the very essence of reality in ways that challenge the current limits of human knowledge. In contemplating this future, we must ask ourselves, what is the ultimate fate of consciousness? Does it have a natural endpoint, or is it a phenomenon that can continue to evolve indefinitely, expanding its reach and understanding of the cosmos? Is the merging of biological and artificial intelligence merely a step on a longer journey, one that leads to even greater forms of awareness and understanding? Could consciousness itself become a form of universal exploration, seeking out not just new worlds, but new dimensions of thought and existence, forever pushing the boundaries of what it means to be aware. In the end, the future of consciousness in the cosmos holds possibilities that are as exhilarating as they are humbling. As we continue to explore the universe, both outwardly and inwardly, we must remember that the evolution of consciousness is not just a matter of technological progress. It is a journey of understanding, of ourselves, of the cosmos, and of the very nature of existence. We are not just observers of the universe, we are participants in its unfolding, and the future of consciousness may be the key to unlocking the deepest mysteries of the cosmos itself. Subsection: Cosmic Islands, the birth of galaxies. Galaxies can be compared to cosmic islands, each containing billions of stars, planets, clouds of gas and dust, as well as mysterious dark matter. These giant structures formed due to the influence of gravity, which concentrated matter into dense regions. The initial density fluctuations in the early universe, which arose during the era of the cosmic microwave background radiation, became the seeds of galaxies. These small concentrations of matter gradually attracted gas and dust, creating increasingly massive structures. Gravity, as the invisible architect of the universe, helped transform scattered hydrogen and helium particles into dense clouds that eventually became galaxies. These early galaxies were far from perfect, small, and unstable, but they laid the groundwork for the complex systems we see today. They grew not in isolation, but through complex interactions with other galaxies. One key process in galaxy evolution was their collisions and mergers. When galaxies collided, their gas and dust mixed, triggering powerful waves of star formation. These galactic dances continue to this day. In the future, our galaxy, the Milky Way, will collide with the Andromeda Galaxy, creating a new giant galaxy. This collision will occur over billions of years, and in its aftermath, a new cosmic metropolis of stars will be born. Subsection: Galaxy Structure and the Role of Dark Matter. The internal structure of galaxies is astonishingly complex. Each galaxy contains billions of stars, interstellar clouds of gas and dust, and an unseen component, dark matter, that plays a critical role in their formation and evolution. Dark matter neither emits nor absorbs light, but it reveals itself through its gravitational influence. In most galaxies, the observable mass cannot explain the force that holds stars and gas within their bounds. This phenomenon is explained by the presence of dark matter, which creates an invisible framework holding galaxies together. Without this hidden component, galaxies would disintegrate under the centrifugal forces caused by their rotation. Dark matter makes up as much as 85% of the universe's mass, and without it, galaxies could not exist in their present form. Galaxies vary in type and structure. Spiral galaxies like our Milky Way have clearly defined arms spiraling around the center. Elliptical galaxies, on the other hand, have more rounded, blurry elliptical shapes and are primarily composed of older stars. Irregular galaxies appear chaotic, often due to the gravitational influence of other galaxies. At the center of most spiral galaxies is typically a supermassive black hole, exerting a significant influence on the entire galactic system. Subsection: The Birth of Stars, the Cradle of the Cosmos. Stars are the true hearts of galaxies, radiating light and heat, creating the conditions for the emergence of planets and potentially life. The birth of stars begins in dense molecular clouds, gigantic clusters of gas and dust. These clouds, under the force of gravity, begin to collapse, leading to the formation of stellar cores. This process can take millions of years, but as the material compresses, the center of the cloud heats up to temperatures of millions of degrees. When the temperature at the core reaches a critical level, nuclear fusion begins, the process by which hydrogen is converted into helium, releasing enormous amounts of energy. This transformation of hydrogen into helium powers stars for most of their lives and makes them shine. Stars can exist for billions of years, but their lives are finite. When a star exhausts its internal fuel, it begins to evolve, going through various stages depending on its mass. Massive stars end their lives in a grand explosion, a supernova, that scatters heavy elements such as carbon, oxygen, and iron into space. These elements become the building blocks for the formation of new planets and even living beings. Subsection: Galactic Collisions, Cosmic Choreography. The splendor of the universe is not only in its vast scales but also in its motion. Galaxies are not static. They constantly move, collide, and merge with each other. These galactic collisions can be seen as a cosmic choreography when two or more galaxies meet and transform each other. Although stars within galaxies don't collide directly due to the immense distances between them, clouds of gas and dust do interact. These collisions trigger powerful waves of star formation, creating new generations of stars. Such collisions continue for millions of years, altering the structure of galaxies and their evolution. The anticipated collision between the Milky Way and the Andromeda Galaxy is just one example of this process. In a few billion years, these two galaxies will merge into a new, more massive galaxy. The central black holes of both galaxies will also merge, creating a new giant object that will become the center of this new galaxy. The grand tapestry of existence. The universe is not merely a vast, cold expanse, but a grand tapestry woven with the intricate threads of time, space, energy, and matter. It is a cosmic masterpiece in constant motion, where every particle, every star, every atom plays a role in the unfolding story of existence. We exist within this fabric, tiny specks against the immeasurable backdrop of cosmic immensity. Yet, despite our seeming insignificance, we are profoundly connected to every atom, particle, and force that shapes the universe. From the subatomic to the galactic, this grand web stretches across unfathomable distances, binding all things into a harmonious whole. Every atom in our bodies was forged in the fiery heart of a dying star, one of the universe's great creators and destroyers. These cosmic ancestors lived and died long before the Earth had cooled from its molten infancy, long before the sun even flickered into existence. In their explosive deaths, known as supernovae, these stars scattered their enriched contents, carbon, oxygen, iron, into the cosmos. These elements, born of the stars, formed the raw material that would become planets, oceans, and eventually, life. Supernovae, like brilliant cosmic fireworks, are not merely destructive forces. They are creative events, the universe's way of recycling matter, of ensuring that each generation of stars and planets is born from the ashes of the old. This cycle of birth, death, and rebirth is the very essence of the cosmos. Without it, there would be no planets to stand on, no air to breathe, no life to live. We are, quite literally, made of stardust, atoms forged in stars that long ago flickered out of existence, their light now a mere whisper traveling across the vast emptiness of space. The understanding of this truth is both humbling and profound. It reminds us that we are not separate from the universe, we are a part of it, an intricate thread in the vast cosmic tapestry. Every breath we take, every thought we have, is a continuation of the same processes that have shaped galaxies, stars, and planets. We are, in essence, the universe reflecting on itself, contemplating its own existence. This realization connects us to the Big Bang, that primordial explosion of energy and matter that set everything in motion some 13.8 billion years ago. Yet, this connection also reminds us of our temporality. We are but fleeting expressions of this cosmic process, our lives but a brief flash in the grand timeline of the universe. The atoms that make up our bodies will one day return to the stars, to be reformed and reborn in new forms of matter, continuing the cycle. In this way, we are immortal, not as individuals, but as parts of the larger cosmic dance. The future, though unknown, is as exciting as it is mysterious. The same forces that shaped us will shape the stars and galaxies of tomorrow. We stand at the edge of cosmic discovery, peering into the universe's depths, seeking to understand not only its past but its future. With every discovery, we unravel a new piece of the grand design, a new thread in the cosmic tapestry. In this vast and intricate web, we are not alone. We share our origins with every star that twinkles in the night sky, every planet that circles those distant suns. Our story is the universe's story, one of continuity, interconnectedness, and endless transformation. It is a tale as old as time itself, written in the language of stardust, light, and gravity. This grand perspective does not diminish us, rather, it elevates us. It places us within the vast, unfolding drama of the universe, a part of a story much larger and more ancient than we can fully comprehend. We are not just observers of this cosmic play, we are participants, and our actions, our curiosity, our quest for knowledge are integral to the story the universe continues to tell. Subsection: Galactic clusters and their role in cosmic evolution. Galaxies do not exist in isolation. They form larger structures, galactic clusters, consisting of tens, hundreds, or even thousands of galaxies bound by gravity. These clusters are the largest structures in the universe held together by gravity. At their centers are often the most massive elliptical galaxies, which continue to grow by absorbing their galactic neighbors. Clusters of galaxies play a significant role in cosmic evolution. The interaction of galaxies within a cluster can lead to the formation of new stars and changes in the structure of galaxies. These gravitational interactions lead to changes in galaxy shapes, sometimes creating stretched and distorted forms as a result of gravitational tug-of-war. Mergers of galaxies within clusters can also lead to the emergence of active galactic nuclei, powerful energy sources associated with the activity of supermassive black holes. These black holes consume surrounding matter, ejecting colossal amounts of energy in the form of X-rays and radio waves. Conclusion: a cosmic perspective. Galaxies and stars are the fundamental building blocks of the universe. Their formation, evolution, and interactions create the endless diversity of cosmic structures. Gravity, as the primary architect, has played its role in shaping these giant islands of matter that merge, grow, and transform. The grandeur and beauty of these processes remind us of how little we know about the cosmos and, at the same time, how much there is yet to discover. We are inhabitants of one of countless star systems, but our understanding of the universe allows us to see its grandeur and complexity. Every new step in the study of galaxies and stars opens up new mysteries and brings us closer to understanding the place we occupy in this magnificent cosmic dance. Chapter 4: Supernovae, Cosmic Fireworks. Supernovae are among the brightest and most powerful events in the universe. These grand cosmic explosions, occurring at the end of the life cycle of massive stars, not only destroy the star but also have a profound impact on the surrounding space. These catastrophic events transform the cosmos, scattering heavy elements like carbon, oxygen, iron, and gold throughout galaxies, enriching their chemical composition and creating the conditions necessary for the formation of new stars and planets. Supernovae are not only about destruction but also about birth. They play a crucial role in the cyclical process of cosmic evolution. Without supernovae, the universe would lack the heavy elements necessary for the formation of planets, atmospheres, and even life. These grand explosions literally lay the foundation for the emergence of future star systems and planetary worlds, like our own. Subsection: Neutron stars. Sometimes, after a supernova explosion, what remains is not total destruction but a highly dense object, a neutron star. This is one of the most extreme and exotic states of matter in the universe. When a massive star collapses under the force of its own gravity, the protons and electrons in its core compress into neutrons, forming an incredibly dense object, a neutron star. A neutron star is so dense that a single teaspoon of its matter would weigh billions of tons. Despite their small size, only about 20 kilometers in diameter, neutron stars possess a mass several times greater than that of the Sun. They are a striking example of how gravity can alter the properties of matter, compressing it to the limits of possibility. Some neutron stars become pulsars, rapidly rotating objects that emit powerful streams of radio waves. Rotating at tremendous speeds, pulsars send out radio signals with incredible precision. These cosmic beacons, like celestial clocks, not only help scientists study gravitational effects but also measure time with astonishing accuracy. Their regularity allows researchers to explore the fundamental laws of physics under conditions of extreme density and gravity. Dark matter, the invisible scaffold. What binds galaxies together? What keeps these colossal cosmic structures, composed of billions of stars, from flying apart as they spin through the vastness of space? The answer lies not in the visible or the measurable, but in the unseen, the mysterious substance known as dark matter. It is an invisible force that permeates the universe, shaping its structure in ways we are only beginning to grasp. Without dark matter, the galaxies we observe would unravel, their stars scattered by the centrifugal forces of their rotation. This invisible scaffold is one of the greatest enigmas of modern science. While it does not emit, absorb, or reflect light, its presence is felt through its gravitational pull. It is as though we are seeing only the shadow of an object, never the object itself, yet the effects are undeniable. Galaxies rotate at speeds that should, by all accounts, cause them to break apart. The mass of visible stars and gas alone cannot account for the gravitational force required to hold them together. Something else is at play, something that far outweighs the visible matter but remains elusive to direct detection. Dark matter forms the backbone of the cosmic web, the vast structure of interconnected galaxies and galaxy clusters that spans the universe. It is thought to make up roughly 85% of the universe's mass, while ordinary matter, everything we can see and touch, constitutes only about 5%. This understanding forces us to confront a humbling truth: most of the universe is composed of something we cannot observe directly, a vast invisible framework upon which the visible universe is built. Despite its pervasive influence, we know little about the true nature of dark matter. Is it composed of yet undiscovered particles? Could it be something beyond the standard model of physics, a new class of matter that interacts with the universe in ways we have not yet understood? The leading theory suggests that dark matter consists of weakly interacting massive particles, WIMPs, which exert gravitational forces but do not interact with electromagnetic forces, meaning they neither emit nor absorb light. Our search for dark matter is a journey into the unknown. Experiments deep underground, far from the interference of cosmic radiation, are being conducted in hopes of detecting a fleeting interaction between dark matter particles and ordinary matter. Yet, despite decades of searching, we have yet to capture this elusive substance. It is as if dark matter exists in a parallel realm, exerting its influence on the universe while remaining frustratingly out of reach. But its impact on cosmic architecture is profound. Dark matter clumps together in massive, invisible halos, drawing visible matter toward it. These halos act as gravitational anchors for galaxies, allowing them to form and maintain their structure over billions of years. In fact, without dark matter, the early universe might never have given rise to the galaxies we see today. Its gravitational influence allowed gas and dust to collapse and coalesce into stars, giving birth to the cosmic structures that now fill the sky. This invisible framework is not confined to individual galaxies. It stretches across the universe, forming vast cosmic filaments, threads of dark matter that link galaxy clusters together in an intricate web. Where these filaments intersect, galaxies and clusters form, held together by dark matter's gravitational pull. In this way, dark matter shapes the very large-scale structure of the cosmos, determining the distribution of galaxies across the universe. Yet, despite its ubiquity, dark matter remains one of the most perplexing mysteries of modern science. Its existence challenges our understanding of reality, forcing us to confront the limitations of our knowledge. How can something so influential remain unseen? What does it reveal about the nature of the universe that so much of its mass is composed of something we cannot directly observe? Dark matter invites us to reconsider what we know about the cosmos. It is a reminder that the universe is far stranger and more complex than we once imagined. It humbles us, as it shows how much of the universe remains hidden, waiting to be discovered. The pursuit of understanding dark matter is not just a scientific endeavor, it is a journey into the very fabric of existence, a quest to uncover the unseen forces that shape the universe. In this invisible substance lies a key to unlocking the deeper mysteries of the cosmos. As we continue our search, we may one day come to understand not only what dark matter is, but how it fits into the grand puzzle of the universe's creation and evolution. For now, we stand at the edge of discovery, knowing that what we see, what we can measure and touch, is only a small fraction of the greater whole. Dark matter reminds us that reality is far more expansive than our senses allow us to perceive. It challenges us to look beyond the visible, to trust that there are forces at work in the universe that transcend our current understanding. The invisible scaffold of dark matter is not just a scientific curiosity, it is a fundamental part of the story of existence, shaping the cosmos in ways that continue to inspire awe and wonder. Subsection: Magnetars. A special class of neutron stars is magnetars. These objects possess the most powerful magnetic fields in the universe, quadrillions of times stronger than Earth's. Magnetars can produce massive bursts of gamma and X-rays, so powerful that they can be detected across vast distances. The magnetic field of a magnetar is so strong that it can deform atoms, stretching them into long chains. If any matter were to approach a magnetar, its atoms would be torn apart by the magnetic forces. This highlights the incredible forces at play in the depths of space and demonstrates how diverse the states of matter in the universe can be. Magnetars are extremely rare, but their study opens new horizons for scientists in understanding how matter and energy behave under extreme conditions. These unique objects remind us that the universe is full of mysterious phenomena that defy our conventional understanding. Subsection: Black holes. When a star's mass is even greater, its end can be even more dramatic. If the collapsing core of a star is too massive, nothing can stop its contraction. This leads to the formation of a black hole, an object so dense and with such strong gravity that nothing, not even light, can escape its grasp. Black holes are perhaps the most enigmatic objects in the universe. They create regions where space and time are so distorted that the familiar laws of physics cease to apply. Around a black hole, there exists the so-called event horizon, the boundary beyond which neither light nor information can escape. Everything that crosses this boundary disappears from the outside world, creating a mystery that scientists still struggle to unravel. Black holes warp space and time around them. As one approaches the event horizon, time slows down for an external observer. This effect, known as gravitational time dilation, is yet another example of how the nature of space and time can be radically altered in extreme conditions. Subsection: Supermassive black holes. The most massive black holes, known as supermassive black holes, occupy the central regions of most galaxies, including our Milky Way. These giants can have masses billions of times greater than the Sun and play a key role in galaxy evolution. Supermassive black holes absorb matter from their surroundings, forming accretion disks that emit enormous amounts of energy, often in the form of X-rays and other high-energy radiation. These black holes exert immense influence on the movement of stars and gas within their galaxies. Their gravity can inhibit star formation by consuming the gas that could otherwise serve as building material for new stars. Yet, they can also create conditions for the emergence of active galactic nuclei, powerful energy sources that shine brighter than thousands of star systems combined. Cosmic expansion and dark energy. While dark matter binds galaxies together in a cosmic embrace, another, far more enigmatic force, dark energy, works to drive them apart. This mysterious energy, which accounts for approximately 70% of the universe's total energy, exerts an influence so vast that it has become the primary driver of the accelerated expansion of the cosmos. As galaxies drift farther from one another, we are witnessing the gradual unraveling of the very fabric of the universe, an expansion that defies the gravitational pull of matter and reshapes the future of everything we know. What exactly is dark energy? This question remains one of the deepest mysteries in cosmology. Unlike dark matter, which we infer from its gravitational effects on visible matter, dark energy seems to operate on a far grander scale. It is not confined to galaxies or clusters, but is instead a force woven into the very structure of space itself, pushing outward, accelerating the expansion of the universe at an ever-increasing rate. It is as if space, the very stage upon which the drama of the cosmos unfolds, is stretching, growing larger, and pushing everything within it further apart. Some theories suggest that dark energy could be a property of space itself, a kind of vacuum energy that exists in the emptiness between galaxies. According to this idea, as space expands, it generates more dark energy, fueling the acceleration of the cosmic expansion. This would mean that as the universe grows, dark energy becomes even more dominant, overpowering the gravitational pull that holds galaxies and clusters together. The result is a universe in which galaxies become increasingly isolated, drifting away from one another into the cold, empty void. Yet, even this theory does not fully explain the nature of dark energy. Is it a constant force, or could it change over time? Some scientists speculate that dark energy might evolve, its properties shifting as the universe expands. Others propose that dark energy could be linked to a new, undiscovered field or particle that we have yet to detect. In this sense, dark energy may represent not just a gap in our knowledge, but a frontier, a doorway into entirely new physics beyond our current understanding. The consequences of dark energy's relentless push are profound. If the expansion of the universe continues to accelerate, it will lead to what cosmologists call the Big Freeze. In this scenario, galaxies will move so far apart that their light will no longer reach one another. Over billions of years, stars will burn out, leaving behind only remnants, white dwarfs, neutron stars, and black holes. The universe will grow cold and dark, as the energy required to sustain life and activity dwindles to nothing. Eventually, even black holes will evaporate through a process known as Hawking radiation, leaving the universe an empty, frozen void. But the fate of the universe might not be so simple. Some theorists have proposed an even more dramatic end, the Big Rip. If dark energy continues to accelerate at an ever-increasing rate, it could eventually overcome all other forces in the universe, including the gravitational and even the atomic bonds that hold matter together. In this scenario, galaxies, stars, planets, and even atoms themselves would be torn apart, as space expands faster than anything can keep up. The universe would end in a violent disintegration, leaving behind nothing but elementary particles scattered across an endlessly expanding space. And yet, despite the monumental scale of these predictions, we are only beginning to grasp the implications of dark energy. Its discovery in the late 20th century was a shock to the scientific community, overturning decades of assumptions about the fate of the universe. Before dark energy was known, many scientists believed that the expansion of the universe, set in motion by the Big Bang, would eventually slow down and perhaps even reverse, leading to a big crunch in which all matter and energy would collapse back into a singularity. But dark energy has rewritten this story, suggesting instead that the universe's expansion will continue indefinitely, reshaping the cosmos in ways we are only beginning to understand. Dark energy forces us to confront the vastness of the unknown. Its very existence challenges our understanding of fundamental physics. Why does it behave as it does? How is it connected to the other forces and particles we know? Could it be linked to a higher dimensional reality, or to the quantum fluctuations of the vacuum itself? These questions push the boundaries of human knowledge, reminding us of how much there is still to learn about the universe. And yet, even in the face of such uncertainty, the discovery of dark energy is a testament to the power of human curiosity and the scientific endeavor. By observing the distant galaxies and the light that has traveled billions of years to reach us, we have uncovered one of the most profound mysteries of the cosmos. We may not yet understand the full nature of dark energy, but each new observation, each new theory, brings us closer to solving this grand puzzle. In the end, dark energy is not just a force of cosmic expansion, it is a symbol of the vastness of the universe itself, a reminder that we are small, temporary beings in an incomprehensibly large and mysterious cosmos. As we look out into the expanding universe, we see not only the stars and galaxies, but the forces that shape them, the invisible scaffolding of dark matter and the relentless push of dark energy. Together, they form the dynamic, ever-changing cosmos we inhabit, a universe that continues to surprise and inspire us with its complexity and beauty. In contemplating dark energy, we are reminded that the universe is not static, it is a living, evolving entity, expanding ever outward, carrying with it the seeds of future discovery. We stand at the edge of this knowledge, knowing that as time marches forward, the universe will grow colder and darker, but also knowing that our understanding of its mysteries will continue to deepen. Dark energy is a force both of separation and of connection. It pushes galaxies apart, yet it draws us closer to the ultimate truth of the universe's fate, urging us to continue exploring, questioning, and reaching for the stars. Conclusion: Cosmic evolution through destruction and creation. Supernovae, neutron stars, magnetars, and black holes are key elements of cosmic evolution. They serve as proof of how the universe creates new forms from destroyed stars, transforming matter and energy into the most exotic states. These grand processes underscore the dynamism of the cosmos, where destruction and creation go hand in hand. Supernovae, by generating new elements, give the universe the ability to evolve, enriching it with the building blocks necessary for creating new star systems and planets. Neutron stars and magnetars show us the limits of density and magnetic fields, demonstrating how nature can transcend our usual understanding. And black holes, by consuming light and matter, remain one of the greatest mysteries that scientists continue to ponder. The universe is a process, and in every destruction, there is potential for new creation. These cosmic phenomena remind us that our understanding of the nature of matter and energy is still far from complete. Chapter 5: Dark Matter and Dark Energy. Our understanding of the universe is constantly evolving as we continue to uncover more of its mysteries. One of the most astonishing discoveries in recent decades is the realization that everything we see, stars, planets, galaxies, even interstellar gas and dust, accounts for only a small fraction of the universe's total mass and energy. Over 95% of its mass and energy belong to mysterious substances, dark matter and dark energy. These invisible builders and drivers of the universe exert a tremendous influence on its evolution, although their nature remains one of the greatest scientific enigmas. Subsection: Dark Matter. Dark matter is a mysterious substance that we cannot observe directly. It neither emits nor interacts with light, nor does it engage with electromagnetic waves in the ways we usually detect matter. However, its presence is felt through the gravitational pull it exerts on visible matter. The very existence of dark matter was inferred by observing the motion of stars in galaxies. Stars on the outer edges of galaxies rotate at such high speeds that the visible mass alone cannot explain why they don't fly apart. This phenomenon led scientists to conclude that galaxies contain much more matter than we can observe. Dark matter creates an invisible framework that holds stars and galaxies together. Without it, galaxies wouldn't be able to maintain their structure, their stars would simply scatter into cosmic emptiness. But what exactly is dark matter? This is one of the most pressing questions in modern physics. The most widely accepted hypothesis is that dark matter consists of so-called weakly interacting massive particles, WIMPs, which do not interact with ordinary matter through electromagnetic forces but manifest themselves through gravity. Other hypotheses include axions, hypothetical elementary particles. Scientists are conducting numerous experiments to detect dark matter in laboratories on Earth, but so far, all efforts have failed to directly observe it. Despite this, its gravitational impact on cosmic structures is so great that scientists are confident in its existence. Dark matter literally shapes the universe, supporting its large-scale structures, galaxies, galaxy clusters, and even the cosmic web made up of interwoven matter stretching across space. A cosmic perspective, the search for life. In our exploration of the universe, one of the most profound and deeply human questions we face is whether we are alone. The discovery of exoplanets, planets orbiting stars beyond our solar system, has transformed our understanding of the cosmos and the potential for life beyond Earth. Where once we saw our planet as a unique oasis in the vastness of space, we now know that the universe is teeming with worlds. Thousands of exoplanets have been discovered orbiting distant stars, and among them, many lie within the so-called habitable zone, where conditions may allow for liquid water, an essential ingredient for life as we know it. But could life on these distant worlds resemble anything familiar to us, or would it be entirely alien? The search for extraterrestrial life forces us to expand our definition of what life might be. We must consider not only the biochemistry of life on Earth, based on carbon and water, but also the possibility that life could arise from entirely different chemistries. Could silicon, with its ability to form complex molecular structures, support life on a planet with radically different environmental conditions? Could ammonia, instead of water, serve as a solvent in biological systems on frigid worlds orbiting distant, dim stars? The diversity of environments in our own solar system suggests that life may arise in the most unexpected places. Europa, one of Jupiter's moons, is a prime example. Beneath its thick, icy crust lies a vast ocean of liquid water, heated by tidal forces from Jupiter's immense gravity. In this dark, submerged world, life could thrive around hydrothermal vents, much like the extremophiles found deep in Earth's oceans. These organisms live without sunlight, relying on chemical energy rather than photosynthesis, demonstrating that life is adaptable and resilient, capable of thriving in extreme environments. Similarly, Saturn's moon Enceladus has shown tantalizing signs of potential habitability. Plumes of water vapor, mixed with organic compounds, have been observed shooting from cracks in its icy surface, suggesting the presence of a subsurface ocean. These plumes contain the basic building blocks of life, raising the possibility that Enceladus, too, might harbor some form of life beneath its icy shell. The search for biosignatures, chemical markers that indicate the presence of life, continues to be a central focus of astrobiology. Scientists are looking for gases like oxygen and methane in the atmospheres of exoplanets, as these are byproducts of biological processes on Earth. If we were to detect a similar mix of gases on a distant exoplanet, it could be a strong indicator of life. Yet, we must remain open to the possibility that life on other planets may not leave the same chemical fingerprints. Alien biology could follow entirely different rules, producing substances we do not yet recognize as signs of life. Beyond biosignatures, the search for technosignatures, signals of advanced civilizations, offers another avenue in the quest to find life beyond Earth. Projects like SETI, search for extraterrestrial intelligence, scan the skies for artificial signals, such as radio waves, that could indicate the presence of intelligent life. So far, these efforts have yielded no conclusive results, but the sheer size of the universe means that the search has only just begun. With new, more sensitive instruments, we are now able to probe deeper into the cosmos, listening for whispers from distant civilizations. What would it mean to find life elsewhere in the universe? Such a discovery would be one of the most profound in human history. It would forever change our understanding of our place in the cosmos. No longer would Earth be the sole cradle of life. Instead, we would recognize that life may be a natural outcome of planetary evolution, perhaps common throughout the universe. If life has arisen independently on multiple worlds, it would suggest that the universe is not merely a physical system, but one in which biology plays a fundamental role. And what of intelligent life? The discovery of a civilization beyond Earth, whether ancient or contemporary, would raise profound philosophical and ethical questions. How would we communicate with beings who may have evolved in entirely different conditions, with minds shaped by a different environment and biology? What would we learn from them, and how would their existence reshape our understanding of intelligence, culture, and technology? Would their civilization be older than ours, perhaps millions of years more advanced, or could they be in the early stages of their own development? Yet, we must also be prepared for the possibility that life, especially intelligent life, may be exceedingly rare. The so-called Great Silence of the cosmos, despite the abundance of planets, may indicate that life faces immense hurdles on the path to intelligence and technology. Perhaps the conditions necessary for life are common, but the leap to conscious, technological civilizations is far more difficult than we imagine. If this is the case, then humanity's existence becomes even more precious, an improbable spark of awareness in a vast, silent universe. Still, the search continues, driven by our insatiable curiosity and our deep desire to understand our place in the cosmos. As we probe the atmospheres of distant exoplanets, explore the icy moons of our solar system, and listen for signals from the stars, we are reminded that we are part of a much larger story. The universe is not indifferent to life, for life itself is a product of the universe. The atoms that form our bodies, the DNA that encodes our existence, were forged in the hearts of ancient stars, scattered across space, and assembled into the complex organisms we are today. In this cosmic perspective, the search for life is also a search for meaning. Whether we find life or not, the quest reveals the interconnectedness of all things. It shows us that life, in all its forms, is a continuation of the same processes that govern the stars and galaxies. It reminds us that we are not separate from the universe, but an integral part of its unfolding story. As we continue to explore the stars, we may one day find that we are not alone. Or we may discover that Earth is one of the few places where life has taken root. Either way, the search for life beyond our planet will forever change how we see ourselves and our place in the cosmos. And in the process, it will deepen our appreciation for the fragile, precious existence we share on this pale blue that we call home. Subsection: Dark Energy. If dark matter acts as a builder, forming the structures of the universe, then dark energy is a force that operates on scales far larger than galaxies. At the end of the 20th century, scientists discovered that the universe is not only continuing to expand after the Big Bang, its expansion is accelerating. This revelation became one of the most startling discoveries in modern cosmology, fundamentally altering our understanding of the cosmos's evolution. Accelerated expansion points to the presence of a force that acts against gravity, pushing galaxies farther apart at an increasing rate. This mysterious force has been named dark energy. It constitutes about 70% of the total energy in matter in the universe, making it the dominant driving force of the cosmos. Dark energy is a phenomenon that remains elusive to modern physics. Its influence is so profound that it could lead to a future where all galaxies, except the closest ones, will drift so far apart that they will disappear from view, even with the most powerful telescopes. This process could reduce the observable universe to a solitary island, our Milky Way, surrounded by infinite cosmic darkness. Scientists continue to develop hypotheses to explain the nature of dark energy. One proposal is that dark energy might be a property of space itself. According to this hypothesis, as space expands, it generates dark energy, further accelerating the expansion of the universe. Subsection: Cosmological Consequences, the Fate of the Universe. Dark matter and dark energy do more than support the structure of the universe and influence its expansion. These forces determine its future. One of the most intriguing questions in modern science is how these forces will shape the further evolution of the cosmos. The most likely scenario at present is the Big Freeze model. If dark energy continues to accelerate the expansion of the universe, all galaxies, except for the closest ones, will cross the event horizon, and their light will no longer reach us. Galaxies will become isolated islands in an ever-growing, empty space. Over time, the stars in these galaxies will burn out, and eventually, the cosmos will turn into a cold and empty place, devoid of energy and life. However, there are alternative scenarios. Some scientists believe that dark energy may change over time, its influence weakening, leading to a slowing or even reversal of the universe's expansion. This scenario is called the Big Crunch, in which the universe would eventually return to a state similar to what existed before the Big Bang, a singularity where all matter and energy are compressed. In this case, the cosmos might undergo a new cycle of expansion, creating a new universe. Subsection: The Search for Answers. Dark matter and dark energy are the two greatest mysteries of our time. They are not only changing our understanding of the universe but are forcing us to rethink the fundamental laws of physics. Currently, we know that 95% of the matter and energy in the universe remains invisible and incomprehensible to us. What are these substances? How do they interact with the rest of matter? The answers to these questions could lead us to a new understanding of the nature of the cosmos. Scientists are continuing to explore dark matter and dark energy using the most advanced technologies. One of the most promising methods for studying dark matter is through experiments aimed at detecting WIMPs in laboratory conditions. Research into dark energy focuses on cosmological observations and models that could provide insight into how it behaves on different spatial scales. One day, we may discover that dark matter and dark energy are two sides of the same phenomenon. Perhaps their nature is linked to new laws of physics that are currently beyond our understanding. These discoveries could reshape our perception of reality and our place in the cosmos. Conclusion: hidden drivers of the cosmos. Dark matter and dark energy are the invisible forces guiding the fate of the universe. Their presence suggests that we are still in the early stages of understanding how our cosmos is structured. Despite all our achievements, the vast majority of the universe remains a mystery. These forces remind us that our knowledge is limited, and even more astonishing discoveries lie ahead. As we continue to explore the universe, our understanding of its nature and future will expand and deepen. We stand on the brink of new discoveries that may change our perception of reality. Dark matter and dark energy are mysterious forces that challenge our understanding of the universe and lead us toward new horizons in science. Chapter 6: Exoplanets and the Search for Life. The discovery of exoplanets is one of the greatest achievements of modern astronomy. It has completely transformed our perception of humanity's place in the universe. Once, Earth seemed unique, thought to be the only place where life could arise. We saw it as a tiny oasis in the vast cosmic desert. However, since the discovery of the first planets beyond our solar system, we've learned that worlds, possibly similar to ours, exist throughout the universe. Thousands of exoplanets have been discovered, many of which orbit stars similar to the Sun. Some of them are at just the right distance from their stars, where conditions might allow the existence of liquid water, a key component of life as we know it. The discovery of exoplanets raises profound questions. If stars with their own planets are spread throughout the universe, how likely is it that life emerged only on Earth? Perhaps life is a natural result of cosmic evolution, widespread and numerous. Exoplanets open up extraordinary possibilities and compel us to consider the diversity of life forms that could exist on distant worlds. The nature of consciousness and the cosmos. As we contemplate the universe in all its grandeur, we must also turn inward and reflect on ourselves. We are conscious beings, endowed with the remarkable ability not only to observe the cosmos but to question it, to seek answers to the deepest mysteries of existence. This capacity for reflection, this spark of awareness, is one of the most profound mysteries of all. How is it that the universe, through billions of years of cosmic evolution, has produced beings capable of understanding their own origins and pondering their place in the vastness of space? Consciousness, this inner awareness of being, raises questions that go beyond science and enter the realms of philosophy, ethics, and metaphysics. Are we unique in the universe, or is consciousness an inevitable outcome of cosmic evolution? Could the same processes that gave rise to sentient life on Earth occur elsewhere, producing forms of consciousness we can scarcely imagine? If the universe is teeming with life, what forms might consciousness take? These are questions that not only challenge our scientific understanding but also touch the core of what it means to be alive. The emergence of consciousness on Earth appears as a wondrous, improbable event. It took billions of years for life to evolve from simple, single-celled organisms to complex, thinking beings capable of self-awareness. Yet, this progression was not guaranteed. Throughout Earth's history, extinction events, environmental shifts, and cosmic impacts shaped the path of evolution. Our existence today is the result of countless fortunate circumstances, from the stable orbit of Earth in the habitable zone of the Sun to the protective magnetic field shielding us from cosmic radiation. But is consciousness a rare cosmic accident, or is it a fundamental aspect of the universe itself? Some philosophers and scientists suggest that the universe may be predisposed to create life and, eventually, consciousness. In this view, consciousness is not a fluke, but rather an inevitable consequence of the universe's laws, a phenomenon that emerges whenever the right conditions are met. If so, the universe may be filled with myriad forms of conscious beings, each shaped by the unique environments of their home worlds. The diversity of possible conscious life is staggering to imagine. On Earth, consciousness is bound by our biology, our carbon-based bodies, the neurons that fire in our brains, the biochemical processes that give rise to thought and awareness. But on other planets, consciousness could arise from entirely different substrates. It might not be bound to carbon or to brains at all. Life based on silicon or some other element could give rise to alien forms of thought that we cannot begin to comprehend. Even more radically, consciousness might not be confined to biological organisms at all, it could exist in forms of artificial intelligence or even as a networked collective of minds spread across a planetary or galactic scale. The possibility of non-biological or distributed consciousness invites us to reconsider the very definition of life. What does it mean to be alive, to be conscious, if the parameters of existence can vary so drastically across the cosmos? Could there be forms of awareness that exist in the spaces between stars, as ethereal entities composed of pure energy, or as vast networks of information encoded in the quantum fabric of the universe itself? These questions stretch the boundaries of our imagination and challenge us to think beyond the confines of human experience. If consciousness is widespread in the universe, what would it mean for us to encounter it? Would we recognize it if it were vastly different from our own experience of awareness? How would we communicate with beings whose perceptions, thoughts, and experiences are shaped by entirely different physical and environmental realities? These questions are not only scientific but ethical. The discovery of alien consciousness would compel us to rethink our relationship with other forms of life, both on Earth and beyond. It would force us to confront our place in the cosmic hierarchy and challenge our assumptions about intelligence, morality, and the nature of existence. Our exploration of the stars is, in many ways, an exploration of ourselves. Each discovery we make, whether it is the detection of a distant exoplanet, the study of a black hole, or the decoding of the cosmic microwave background, sheds light on the nature of existence. In the process, we learn not only about the universe but about our own consciousness, our capacity for wonder, and our desire to understand. We come to realize that we are part of something far greater than ourselves, connected to the cosmos in ways that are both intimate and profound. Consciousness, it seems, is the universe's way of reflecting on itself. Through us, through our thoughts, our questions, and our search for meaning, the universe becomes aware of its own existence. We are not separate from the cosmos, we are a product of it, an extension of the same forces that shape the stars, galaxies, and planets. Our awareness is a continuation of the processes that govern the universe, from the quantum fluctuations in the earliest moments of the Big Bang to the complex neural networks in our brains. Yet, consciousness is also a mystery we have yet to fully understand. How does matter give rise to mind? How do atoms and molecules come together to create subjective experience? These questions remain unanswered, and they hint at the possibility that consciousness may be more fundamental to the universe than we currently believe. Some theories suggest that consciousness could be a basic property of the universe, woven into the very fabric of space and time, much like gravity or electromagnetism. In this view, consciousness is not something that emerges from matter, but something that exists alongside it, a fundamental aspect of reality itself. This idea, sometimes referred to as panpsychism, challenges our conventional understanding of mind and matter. It suggests that consciousness might not be limited to complex organisms with brains, but could be present in some form even in the simplest particles or systems. While this theory remains speculative, it opens up intriguing possibilities about the nature of the universe and the role that consciousness plays within it. As we continue to explore the cosmos, we may one day discover the answers to these profound questions. We may find that consciousness is a universal phenomenon, shared by countless beings across the stars. Or we may learn that it is a rare and fragile occurrence, unique to a few planets in an otherwise lifeless universe. Either way, the search for understanding will deepen our connection to the cosmos and to each other. In contemplating the nature of consciousness, we are reminded of the vastness of the universe and the complexity of our own existence. We are conscious beings, capable of experiencing the wonder and mystery of the cosmos, and in that experience, we find meaning. The universe is not indifferent to us, for we are a part of it, and through our consciousness, it reflects on its own creation. In the end, the search for consciousness, both within ourselves and beyond, is a journey into the heart of the cosmos itself. It is a quest to understand not only what we are, but what the universe is, and what role consciousness plays in the grand story of existence. And in that search, we may come to realize that consciousness is not an accident of the universe, but one of its most fundamental and beautiful expressions. Subsection: Biosignatures and Technosignatures. The key question in the search for life beyond Earth is how exactly to find it. Scientists have focused on searching for so-called biosignatures, chemical traces that might indicate biological processes. On Earth, for instance, oxygen and methane in the atmosphere are byproducts of living organisms. If we find an exoplanet with an atmosphere containing these gases in similar proportions, it could be a strong indicator of life's presence. However, we must be prepared for life to take the most unexpected forms. There are planets whose chemical compositions may differ greatly from those we are familiar with on Earth. For example, on some worlds, instead of water as a solvent, life might use liquid methane or ammonia. In such places, life forms could evolve based on elements and chemical processes impossible on Earth. Another area of exploration is the search for technosignatures. Technosignatures are artificial signals that may indicate the existence of intelligent civilizations. These could include regular radio signals or even evidence of megastructures, such as a hypothetical Dyson sphere, built to harness the energy of a star. The SETI project, aimed at searching for such signals, continues to seek proof that humanity is not alone in the universe. The possibility of discovering technosignatures opens up grand prospects. Encountering evidence of intelligent life would revolutionize our understanding of the cosmos and our place in it. It would not only be a scientific discovery but a philosophical shift in how we perceive the universe and our connection to it. Subsection: Life on the moons of giant planets. When we search for life beyond Earth, we usually focus on exoplanets in the so-called habitable zones. However, scientists are increasingly turning their attention to less obvious places where life might arise, the moons of giant planets. In our solar system, Jupiter and Saturn have moons that may be far more promising for the search for life than we once thought. One such moon is Europa, a moon of Jupiter. Beneath its thick icy crust lies an ocean of liquid water that could potentially support life. On Earth, we know that even in the most extreme conditions, deep in the oceans where sunlight does not penetrate, life thrives, drawing energy from hydrothermal vents. It's possible that exotic forms of life could exist in the subsurface oceans of Europa or Enceladus, a moon of Saturn, feeding on chemical energy released from the planet's interiors. These places offer a new perspective on where life might exist. If Europa and Enceladus can hide oceans full of life, it radically changes our understanding of where and how biological organisms can arise. Entire ecosystems could exist in the depths of these worlds, expanding the boundaries of our imagination. Subsection: The possibility of exotic biospheres. If life can exist in the oceans beneath the surfaces of icy moons like Europa and Enceladus, it begs the question, how diverse could biology be across the universe? What chemical elements and reactions might underlie life in other worlds? There are theories suggesting that life could be based not on carbon, as on Earth, but on silicon. Such life forms could exist under conditions that seem extreme or even lethal to us. Perhaps on planets with extreme temperatures or pressures, biology takes entirely different forms than those we know. Life based on ammonia or methane could exist on cold worlds where water remains frozen. Such life forms might utilize chemical processes that seem impossible by Earth standards. These exotic biospheres could drastically alter our understanding of biological processes and show how adaptable and resilient life can be. Each new world we discover shows us that life could emerge in the most unexpected conditions. Questions about what kinds of life might exist beyond Earth go beyond biology and physics, they touch on the very definition of life itself. If life is so diverse, what types of intelligent beings could evolve under conditions so different from our own? Conclusion: a cosmic perspective. The discovery of exoplanets and the exploration of icy moons offer a new understanding that life may be more widespread and diverse than we ever imagined. These studies not only push the boundaries of science but also raise fundamental philosophical questions about humanity's place in the universe. With each new discovery, we come closer to answering one of the oldest questions: are we alone? Perhaps life is not an exceptional phenomenon but a natural outcome of planetary system evolution. Each new world we discover reveals that our universe is full of possibilities for life and intelligent beings. Every discovery is another step toward understanding how the cosmos is structured and how we fit into this grand picture. We stand on the threshold of discoveries that could change not only our perception of the universe but also our place in it. And perhaps, one day, we will find that life exists not only on Earth but on other distant worlds waiting to be discovered. Chapter 7: The Future of Space Exploration. Humanity has already taken its first steps beyond its home planet, sending missions to the moon and dispatching exploratory probes to other celestial bodies. However, these achievements are merely the beginning of a grand journey that awaits us in the future. We stand on the threshold of a new era of space exploration that could forever change our perception of the universe and our place in it. Every new mission, every launch, is an opportunity to take a step forward, get closer to new discoveries, and expand the horizons of knowledge. Questions about the future of space exploration are becoming increasingly relevant. Space exploration is not only about scientific discovery, but also the key to humanity's survival. In the face of global challenges such as climate change, resource depletion, and threats from cosmic objects, our ambitions to explore other worlds take on special significance. Space is not just a new frontier for exploration, it is an opportunity for humanity to transcend its limitations and secure a future beyond the fragile ecosystem of one planet. Subsection: The colonization of Mars. Mars, Earth's nearest neighbor, is the most realistic candidate for colonization. The red planet has long attracted the attention of scientists, explorers, and visionaries. We know that Mars has polar ice caps, and there may be significant water reserves beneath its surface. This makes Mars a unique planet for both research and colonization. Today, robotic explorers like rovers are already working on the surface of Mars, sending valuable data about its geology, atmosphere, and the potential for life back to Earth. The next step, however, is to send humans to Mars, which would be a monumental achievement for humanity. Such missions will offer unprecedented opportunities for scientific discoveries and the development of new technologies. Colonizing Mars is not only a technical challenge, it is a question of humanity's survival and adaptation to new environments. The Martian atmosphere is thin and consists primarily of carbon dioxide, making it unbreathable, but also a potential source of oxygen production. With new technologies, we can create closed ecosystems that will allow humans to survive on the surface of Mars by using its resources to sustain life and build infrastructure. However, one of the most important issues surrounding the colonization of Mars is ethics. What if microbial life exists on Mars? How should we proceed if such life is discovered? Should we protect these forms of life, or does humanity have the right to continue exploring and transforming the planet into its new home? These questions will become increasingly significant as we move closer to the practical exploration of Mars. Subsection: Space missions beyond the solar system. Our dream of traveling beyond the solar system, once the realm of science fiction, is drawing closer to reality. Projects such as Starshot propose new methods for interstellar missions. These missions may rely on solar sails that use light pressure to accelerate small spacecraft to speeds approaching the speed of light. Such probes could reach the nearest stars, like Alpha Centauri, within a few decades. These missions represent a revolution in space exploration. For the first time in human history, we will be able to gather direct data about planets around other stars, study their atmospheres and surfaces, and search for signs of life. Interstellar missions will also help us understand how common Earth-like conditions are and what types of life may develop on other planets. Venturing beyond the solar system is not merely a scientific achievement. It is a key step in understanding our place in the universe. If we discover that life exists on other planets, it will fundamentally change our perception of Earth and humanity's uniqueness. But even if life proves rare, it will also compel us to reassess our relationship with the planet that sustains life and recognize its invaluable importance. Subsection: A lunar base as a step toward space exploration. Before venturing into the far reaches of space, humanity must take an important step, establishing a permanent base on the Moon. As Earth's nearest satellite, the Moon is an ideal launching pad for space exploration. It is close enough to ensure safe logistics and the quick delivery of supplies and crews. Establishing a lunar base would give humanity the opportunity to test technologies for survival in extreme conditions and long-term space missions. A lunar base could become a scientific laboratory for studying new materials, energy, medical technologies, and life support systems necessary for space exploration. The Moon also offers unique opportunities for mining resources such as helium-3, which could become the foundation for new energy sources. Additionally, on the Moon, we can study how the human body adapts to low gravity and extended space missions. This experience will be invaluable for future expeditions to Mars and other distant objects in the solar system. Subsection: Ethics and Philosophy of Space Exploration. Space exploration poses not only scientific and technical challenges but also important philosophical and ethical questions. What does the colonization of other planets mean? What are our responsibilities to the ecosystems we may discover? What should we do if we encounter extraterrestrial life? These questions touch on not only scientific progress but also our role as an intelligent civilization in the universe. If we discover life on other planets, even in the form of microbes, it will raise questions about how we should interact with this life. Should we protect it, or should we continue our exploration regardless of its presence? These questions may become central to the future ethics of space exploration. Moreover, space exploration makes us reconsider how we use the universe's resources. If humanity begins to mine resources on other planets or asteroids, it will require a responsible approach to avoid repeating the mistakes made on Earth. We must consider the long-term consequences of our actions and strive for sustainable exploration of the cosmos. Conclusion: A cosmic perspective. The future of space exploration promises exciting discoveries and great achievements. We stand on the brink of a new era in which humanity will be able to venture beyond Earth and become a truly spacefaring civilization. But this future will require not only scientific and technological advancements, but also a deep understanding of our responsibilities to the universe. Space exploration is an opportunity for humanity to overcome its limitations and explore new horizons. With each new step into space, we come closer to the moment when we can answer the great questions about life, intelligence, and our place in the universe. We are on the verge of grand discoveries, and while the journey will be challenging and long, humanity will continue its cosmic voyage, striving for new horizons and unexplored worlds. Chapter 8: The Fate of the Universe. The universe is an unstable and ever-changing system, immersed in motion and evolution. Today, we have the ability to not only look into its distant past but also to contemplate what might lie ahead. Scientific theories present various scenarios for the future of the cosmos, from gradual decay to grand catastrophes. These scenarios not only pique our interest in physical processes but also prompt us to reflect on our role and destiny in this vast cosmic tapestry. Subsection: The Big Freeze. One of the most likely scenarios for the end of the universe is the Big Freeze, also known as heat death. According to this model, the universe will continue its expansion, accelerated by dark energy. Stars will gradually burn out, becoming white dwarfs, neutron stars, and black holes. Over time, matter will disperse, and the temperature of the universe will approach absolute zero. It will be a world where energy becomes so diffused that it can no longer sustain any active processes. Star formation will cease, and black holes, evaporating through a process known as Hawking radiation, will eventually vanish. The universe will be left as a dark void, devoid of light and heat. Despite the seeming inevitability of this scenario, it raises many questions. Could consciousness or life persist in such a world? Could new ways of preserving life be discovered, allowing it to continue even under these conditions? Perhaps intelligence itself will have to evolve to adapt to this cold and empty reality. The question of what might follow our current understanding of life and mind remains one of the greatest mysteries of the future. Subsection: Alternative Scenarios. There are many other possible scenarios for the end of the universe, each dramatic in its own way. One of them is the Big Rip theory. This scenario suggests that the universe's expansion will accelerate so much that gravitational forces will no longer hold stars, galaxies, or even atoms together. Ultimately, all structure in the cosmos will be torn apart. Unlike the slow decay of the Big Freeze, the Big Rip describes the universe's end as a rapid disintegration. Everything we know will break down into fundamental particles, and matter as we understand it will cease to exist. This is a scenario of absolute separation between all forms of matter. Another possibility is the Big Crunch. According to this theory, the universe's expansion may eventually slow and then completely stop. When that happens, gravity will once again dominate, causing the universe to collapse. This contraction will bring all galaxies, stars, and planets back to a single point, a new Big Bang. This scenario provokes intriguing thoughts about the cyclical nature of the universe's existence. Perhaps the universe exists in an endless cycle of explosions and collapses, each one giving birth to new physical laws and galaxies. In every new phase of this process, new forms of life could emerge, different from anything that existed before. Subsection: Cosmic Horizons, the role of human consciousness. These scenarios about the universe's fate inevitably lead us to reflect on time, life, and the role of consciousness. In a world where even stars and galaxies are destined to disappear, the question of what will happen to the mind becomes central. Could human consciousness continue to exist in such a changing cosmos, or is it, like everything else, doomed to disintegrate? Human consciousness is the phenomenon that allows us to contemplate and explore these questions. In a sense, we are the part of the universe trying to understand its own fate. If one day consciousness can evolve to resist the end of time and space, we may hope for continued existence even in the most extreme conditions. Our reflections on the fate of the universe also make us think about the nature of time. For us, time may seem like a limiting factor, but what if there are ways to overcome that limitation? Could consciousness one day break free from the bounds of space and time, finding new ways of existence? These philosophical questions are becoming more relevant as science draws closer to understanding the fundamental laws of the cosmos. Conclusion: A cosmic perspective. When we contemplate the fate of the universe, we realize its vastness and incomprehensibility. We are tiny creatures on a small planet, yet our consciousness allows us to grasp the entire cosmos, its past and its future. The questions about how the universe will end touch not only on physics but also on philosophy, raising fundamental questions about the meaning of existence, life, and intelligence. The future of the universe remains uncertain. Will it fade into silent emptiness, be torn apart, or return to a new phase of existence? We don't know. But in the process of seeking these answers, we uncover not only new dimensions of reality but also new aspects of our own existence. We are not merely observers of the universe, we are part of it, a product of it, endowed with the ability to reflect and explore. Every discovery, Every theory about the universe's future brings us closer to a deeper understanding of its nature and, perhaps, to the realization that life and consciousness play a key role in this grand cosmic drama. We are at the beginning of a journey toward understanding this boundless story, and our drive for knowledge is an essential part of our journey through space and time.